So, welcome to the Parker booth here at Bauma 2025. Parker is proud to be the global leader in motion and control technologies. Here at Bauma, the theme is technology inside that moves your world. And Parker is here at Bauma to fulfill your wildest engineering dreams and to partner with OEMs in mobile machinery and off-road applications. What that means is we want to help you find the answers to increased efficiency, to improved safety and intelligence in your off-road applications, and all that while reducing emissions. No small task. For our live talks here, we have gathered, come in and take a seat. We have gathered our global experts from all over the world to share their immense experience and their insights on the 4 key themes here at the booth. And those themes are clean tech, electrification, digitalization, and mobile hydraulics. In our first talk, do come in, take a seat. It's very cozy here. Come in and take a seat. In our first talk, we're going to be diving into how to get to zero emissions in off-road applications, and we will be focusing on agricultural and construction machinery. What we want to do is give you a good overview of trends and, of course, technological advancements in order to achieve carbon neutrality, and we'll have time for your questions after our talk. So let's get started. It's my pleasure to introduce our 2 speakers from Cleveland, Ohio, where he is director of the Parker Motion Technology Center. It's his first time at Bauma, so please give a warm welcome to Jeff Ostermann. Hi, Jeff. And leading the clean tech team here at the Parker booth, he is here at Bauma for second time. Yep. He's product manager, alternative technology at Parker in the R&D Center in Stuttgart. Please give a warm welcome to Robert Jozsa. Yep. Hi, Robert. So, Jeff, you've been at Parker for almost 30 years. First time at Bauma. What brings you here?
See electrification, understand the customers, the suppliers, growing trends, and how we can help the world.
Okay, great to have you here. And Robert, you're based in Stuttgart in the R&D Center. Can you tell us in a nutshell what your current focus is, what you're working on?
Yeah, so we are focusing on decarbonization and all the different filtration solutions which come with this.
Okay, thank you. That was a good nutshell. Wonderful to have you both here. Now, dear visitors, a few weeks ago on LinkedIn, we had an opinion poll on what you think is driving the future of the off-road mobility. So let's take a look at that. The questions, we'll show you the results of the opinion poll in just a minute. But I'd like to see a show of hands if we go through these. Who thinks electrification is driving the future of off-road mobility? If you have a show of hands? Okay, the majority, it seems like quite a few of you. Obviously, Jeff. Hydrogen fuel cells. Anyone think hydrogen fuel cells is the future of off-road mobility? Oh, well, you put your hand up twice. Doesn't quite count. Advanced diesel. Anyone think advanced diesel is the future of off-road mobility? No hands there. And optimized ICEs? No hands there. So, Robert, let's see what were the results of the opinion poll on LinkedIn. Right. And what did you think? How did that compare to the answers here?
Yes, here we see more electrification as a target, but I was very excited that online we at least see hydrogen as a potential solution.
Yeah, big difference to the crowd here, and we'll discuss amongst the 2 of you what you think the answers are. So, Robert, starting off big picture, in light of global movement towards decarbonization, what are the key factors influencing the transition to lower emissions now, specifically in agricultural and construction machinery?
Yeah, so overall, the target is climate neutrality, and we want to make sure that we have clean technologies for that. Like if we look, for example, on CO2 emissions in the EU, in 2019, we had approximately 2.6 billion tons of CO2 emissions. This has been going down, so now we are looking at 3.2 billions. Transportation sector is 25%, so we need to make sure that this is being reduced. The non-road mobile machinery sector is approximately 3% at 110 million tons of CO2, which is a large number. And out of this, 75% is looking at agriculture and mining equipment. So focusing on these technologies, we need to make sure that also this segment is going down with the CO2 emissions. Now, if we look at this segment of non-road mobile machinery, there are several factors which are influencing this transition. We have regulatory framework. There are new emission standards which are being developed. We have Euro 7 for the on-road vehicles and Stage 6 for the off-road side, and this will be probably implemented in 2030. Now, these new emission standards are focusing on hydrocarbons, NOx emissions, CO emissions, and particulates, but the CO2 will probably be missing. So on the on-road side, we have the Green Deal, which has strict targets for 2025, 2030, 2040, and this is looking at the whole fleet CO2 emission, but for non-road machinery, this is missing. So something needs to be implemented. The second point is economic considerations. We need to make sure that all these new technologies have a low total cost of ownership, and this will also drive the selection. So this will going to be an important point. Customer preferences. We see more and more customers looking for sustainable solutions from us. So we need to make sure that we are developing sustainable solutions and everybody can reduce the CO2 emissions. Technology advancements. These new technologies, green technologies, are more advanced on the on-road side. And once these are going to get closer to mass production, the implementation in the non-road mobile machinery sector will be more attractive. And I think the last point is supply chain. We see an increased need of having local sourcing and making sure that you are keeping your technology advancements. But overall, when you look at greenhouse gas emissions, it's the fuel, which needs to be fossil-free fuel, and the overall efficiency of the complete vehicle.
Okay, great. Thank you. That's a very good overview of all the things that need to be taken into consideration. So, Jeff, in this specific sector, considering duty cycles and power usage of the equipment, what strategies can manufacturers implement in order to promote a cleaner and more sustainable future?
Okay, strategies to promote a cleaner future. Electrification produces zero emissions at the source. Very low emissions if it's from a greener sources like wind, wave, and solar. Uptime and efficiency are really important. Batteries are the biggest cost in some of these vehicles. Also, customers really want to charge in the morning, run all day, not have to recharge during the day. Optimal strategies to maximize this efficiency. Really, it's getting the vehicle, mapping out where the energy is used, understand that energy usage by function, replace internal combustion engine with high performance, high efficiency motors and inverters, change from a centralized to a decentralized hydraulic system. Electromechanical actuators, electrohydraulic actuators are perfect to reduce pump losses, to reduce valve losses, and keep them at a very minimal level. Decouple functions, only use those functions when needed. Increase pump speeds to match the efficiency sweet spot of the electric motor. Recover energy by taking the motor, changing it to a generator, and putting energy back into the battery. And last, these strategies we've seen in our own labs at Parker Hannifin have been able to improve our overall efficiency of the functions from 15% to 70%. If anyone's interested, come see me in the booth and we can talk through some of that information.
That sounds like quite a considerable percentage in efficiency. Are you surprised by that?
It did surprise us when we went through it, but through a lot of diligence and many different iterations, we were able to achieve it.
Okay, fantastic. Robert, in examining the powertrain solutions and the use of renewable fuels, which technologies are best suited for this particular sector?
Yeah, the target is, of course, climate neutrality. And we already, but this does take a long time. So we have intermediate solutions which will help in this journey. So we have advanced diesel solutions, hybrid solutions, different fuels, HVOs. But for climate neutrality, we will need fossil-free technologies. Especially in this segment, which we have here, there are several factors which will depend which zero-emission solution is selected. So probably the most important one will be efficiency. This is leading the fuel cost, the operational cost. So this is going to be a driver. However, we are looking at the uptime of the vehicle, whether it needs to run for a long periods of time, like harvesters, for example, in summer, or it has an operating cycles. We are looking at the mobility of the equipment, whether it needs to travel long distances or it's more of a stationary application and you can connect it to the grid. important one is the power rating. If it has a very high power rating, then if you want to use batteries, you are going to require a large amount of batteries to be able to store that. And then the refueling and the recharging infrastructure is also important. So we need to make sure that all of these factors are being considered when the technology is selected.
Okay, I mean, we've got a great overview of technologies and challenges. We haven't talked about cost yet. Now, maybe just zooming in, Jeff, how do the prices of internal combustion vehicles compare to battery electric vehicles? If you can give us a sort of a general idea of the considerations there and price.
Yep. So when you look at the prices of internal combustion engine vehicles versus battery electric vehicles, it varies by region and type of machine. The price gap is smaller on smaller vehicles that have lower power, lower voltages. You see industrial forklifts have been in the market for a very long time. You look at their internal combustion engine counterparts versus battery electric, it's almost a 1-to-1 price for the machine comparison. You start getting into mini construction, you're talking, mini excavators, walk behind skid steers, 1.2, 1.4. So electric is more expensive, but it's approaching about the similar price level. And then you get to very large vehicles. A good example is on highway truck. So you see semi trucks on the highway, lots of power, big size, 2 to 3 times could be the cost of the vehicle. Mm-hmm. Government subsidies are something that helps propel that going forward.
Okay, and similar to the automotive sector, the more this technology becomes spread, and then hopefully the costs will be going down as
That's
well,
correct.
and hopefully with government funding too. So while the market is actively exploring various solutions, which you gave us a good overview of, what do you believe will emerge first, Robert?
I mean, probably first is going to be the battery electric vehicles or battery solutions. If you look at efficiency, the most efficient solution, especially in this sector, is an electrically driven machine, which is connected to the grid.
Right.
This way you don't need to have time for recharging, and you also have lower costs with eliminating batteries. However, the second one would be the battery electric vehicles. These also have a very high efficiency, as Jeff was mentioning. However, you do have downtimes with recharging or battery swapping. Mm-hmm. So those are the most efficient solutions. Outside of these, the alternatives when we are talking about clean technology will be hydrogen. And from hydrogen point of view, we look at fuel cell systems or hydrogen combustion engines. Now, a fuel cell system is very similar to a battery electric vehicle on the idea that it uses electricity, an electric motor which uses electricity, but the electricity is not stored in the battery, but is generated on the vehicle. From efficiency point of view of the fuel cell system itself, we are looking at 50-60%. But the major advantage of the system will be the refueling time, where you can refuel it similar to diesel applications, and the weight of the hydrogen which is stored on the vehicle. These are the biggest advantages. Of course, you have challenges here. It's a sensitive solution, so you need to make sure that all the air and the hydrogen is cleaned and all the particles are removed, as well as we need to consider shocks, vibrations, and the thermal management of the system. It requires a significantly better thermal management than a diesel application.
Okay, just briefly interluding there. So you say electric is, as long as you're connected to the power grid, the simplest solution for the moment, or the most viable. But I mean, in Europe, the power grid is not so reliable. Do you have any numbers, with talking about this power grid connection and whether that's really working in Europe?
At the moment, it doesn't.
Yeah.
So it needs to be built up.
Yeah.
If we are changing to clean solutions, it does need to be improved and it needs to be upgraded. I don't think personally that electrification or battery electric vehicles will be enough, because that's also a major growth, right, for the infrastructure. And due to the different factors and the different matrices, that we have in this, all those different configurations of vehicles, hydrogen will be there. And outside of fuel cell, we have the hydrogen combustion engine, which I think, especially in this sector, might be more attractive, just due to the fact that it's not a completely new technology. So we are upgrading an existing combustion engine technology. And of course, we are going to burn hydrogen instead of fossil fuel, and it's not 100% clean. However, the CO2 emissions which are being generated are close to zero, and the NOxes can be filtered out with after treatment solutions, so it's still attractive. And in this segment, a lot of the manufacturers will be able to maintain their technological advancements, as well as the workforce significantly easier than to go to completely fuel cells.
Okay, and if anyone is interested here in the audience about the fuel cell technology, which you can also apply to hydrogen combustion engine, you've got the clean tech wall over there, and Robert will take you through that, I'm sure, very, very proudly. Now, it seems there are various options here, and your specialization is electrification. What would you say is a segment leader, perhaps also comparing US to Europe?
As far as who's ahead or
yeah,
behind?
which technology?
For hydrogen or for electric?
Comparing both.
Comparing the two? It seems like, I mean, the US has slowed down as far as electrification goes. Europe is still strong support from the government. And then Asia is really strong as far as electrification goes. I'm not sure on hydrogen.
Yeah, on hydrogen, I think Asia is the most advanced at the moment, at least on numbers of vehicles on the road. On development side, Europe is also pushing hard and working on developments. There are a lot of demonstrators which we have on the field, and there are a lot of funding opportunities with the government. So I think these are the front runners, but USA is also working on all of these technologies because everybody needs to be climate neutral.
Okay, so let's say I'm an OEM and I've decided for electrification. Jeff, how is Parker facilitating the electrification of the market?
Yeah, Parker Hannifin, we've got a motion technology center in Cleveland, Ohio. We've got some of the best experts in the industry, and they're just dedicated to electrification. We're developing the next generation of high-efficiency inverters using the latest switching devices. We're able to get 7 to 10% efficiency gains, which is a lot in these electrified vehicles to save on battery and battery recharge times. We've got electric motors around propulsion and pump applications, and 850 volts seems to be the growing trend, and I'm seeing that more and reinforced here at the show. E-pump controls is a big thing we're working on at the Motion Technology Center. How do you have a pump and a motor work together to have the most efficient system on a customer's vehicle? High-speed piston pumps. So, a lot of our piston pumps are developed after World War II with diesel engines, 2,500 RPM. Well, the sweet spot of a lot of these electric motors for efficiency, 5,000 RPM. Parker's working on that challenge to get our piston pumps able to get up to 5,000 RPM. We're engaged with some of the top universities in the world with research, and that's evident by the numerous patents and new products that we've developed. We're hiring top talent from these universities to be the next generation of hydraulic and electrical engineers. And our purpose statement really, when you look at it in Parker, it really lines this out and talks through enabling engineering breakthroughs that lead to a better tomorrow.
Thank you for that overview, Jeff. Now, if there was one thing that you'd like to point out on the electrification part of the booth here, what would you like to show an OEM partner?
I think the big item would be our motors and inverters. We've got a nice complement between our GVM and our GVI product lines. We're ready for propulsion and pump applications, and really to minimize or maximize the efficiency, minimize their energy usage.
Okay, so that's something you can show and tell here
That's
on
correct.
the booth, and you can go over there with anyone who's interested in that in particular. And clean tech in general, you're the clean tech expert here, Robert. How is Parker facilitating clean tech?
Yeah, I think hydrogen is part of this journey, so that's important. I think what Parker has to offer is the wide range of products that we are developing, which are related for hydrogen. So we have decades of expertise with the industrial sector and with the mobile sector, so we are able to develop these new technologies to the highest standards and validate them to the highest standards. So we have handling and conveyance of hydrogen on the vehicle, so we have leak-free solutions for that. Additionally, all these new technologies require high level of filtration. So we are working on new and innovative solutions. Our Parker Filtration Innovation Center is leading this development, whether it's cleaning the air and working on making sure that the air that gets to the stack is optimal condition. We have cathode air filters, humidifiers for that, as well as filtering out the hydrogen and making sure that everything runs correctly. Additionally, probably the thermal management of the system is a critical point. So we have developed high efficiency system solutions, to make sure that the whole system works well and for a long time. So I think if you want to come here and look at the Parker booth, you are welcome to come to the clean tech wall and consider Parker as a one-stop shop.
Okay, thank you so very much. We'll open the floor to questions. Would you like to ask our experts anything at all from what you've heard here? Is there anything you'd like to know more? Show of hands. Anyone want to add a question? The gentleman here in the front row. Yeah, if you could speak loud and clear, then we can all hear your question and learn from that.
Question for Jeff. Just wanted to get your view on the cost. You mentioned about the cost of electric powered vehicles. Logically, I would think that in the future, an electric vehicle is going to be much lower cost to produce than an ICE. What's your thoughts? And actually, we've seen some of that coming from potentially from the Chinese vehicles being pushed now even into the European market at super low prices. I don't know what your perspective is on that.
Yeah,
Thanks.
The same. I've got people on my team that used to work for the automakers, and you see the push there, real high volumes for all these inverter motor technologies. So yeah, we see as economies of scale, it's a progression. A lot of internal combustion engine, a lot of hydraulics have been around for many, many decades, even centuries, right? It's taken time to get to the point where we are, and electrification, it's the same. I think it'll be a big focus here as we, get the volumes, get the technology where it needs to be.
Any further questions from the floor? Thank you for yours. Okay, I have another question, maybe while you're still thinking about it, if there's something you'd like to know. What do you believe the market needs, Robert, in order to accelerate the implementation of clean technologies?
Especially in this segment, I want to say regulation needs to come. As I mentioned, there are no regulations for CO2 emissions and the on-road mobile machinery. So this needs to be implemented, and it needs to look at the whole vehicle. So not only tailpipe emissions, but the complete efficiency of the vehicle. Additionally, we need to have infrastructure. So you need to make sure that we have hydrogen or recharging infrastructure, whichever it is, that needs to be implemented. And for this, in Europe, as for example, we have the alternative fuel infrastructure law, which is working on building up the infrastructure for alternative fuels, which is recharging and hydrogen. And we need to make sure that the non-road mobile machinery is part of this discussion. Additionally, probably we need to have R&D investments and government funding to make sure that it's more attractive and people are working on this.
Okay, and for electrification, would you add anything to that? What the market needs in order to promote this?
Yeah, I think the big thing, like he mentioned, was regulations and then the charging infrastructure, getting the costs down, as we mentioned, on these vehicles. So costs get closer to parity with internal combustion engines, get the ability to recharge, and then government regulation around, getting carbon emissions down is important.
Okay, we haven't talked about the cost of hydrogen. Any insights you can give us there, Robert?
It's high at the moment, but it needs to go down. So I think there are a lot of projects, for electrolyzer and making green hydrogen. There are definitely targets within the European Union for the next years on the amount of hydrogen which we need to produce. I think once the scaling will be higher, the price will go down, and it can be an attractive solution.
Okay, fantastic. Thank you so much for this overview on how to get to zero emissions. And you will be at the clean tech area here. Do take a look around. And will you be at the booth today still?
I'll be in and out of the booth, yes, all day, today and tomorrow.
So grab Robert or Jeff, clean tech, electrification, if you'd like to know anything more. And our next talk will start here at 1 o'clock with more experts from around the globe from Parker. And we'll be focusing on electrification technologies in more detail. Hope to see you later at 1. Thank you for your attention. Thank you, gentlemen.